Wands don't exist in the real world. They were smelting iron and popping out Model Ts. What is a barcode? That sounds like the dumbest idea I've heard this month. Oh, I'm excited for this. I'm so excited for this. Hang on, let me see if I'm going to get in trouble. Why is hardware so hard? That's all why. Good afternoon, everyone, and welcome to the Slant 3D podcast, the show about 3D printing and our place inside the industry. Today, we're going to be talking about Starbucks 3D printing their new stores and how the entire industry is declining. But then ultimately, finishing off with your questions as per usual at the end of it all, and discussing why hardware startups are so much harder than regular software startups. But before that, let's go ahead and pay the bills. This episode is brought to you by the Bambu Lab A1 combo. If you've been looking for the perfect first 3D printer, or just need a printer that's easy and quick to set up right out of the box, you should check out the Bambu Lab A1 combo. This is a partially assembled but quick to set up machine that is both fast and incredibly precise. With its Cartesian motion system and active vibration compensation, it delivers smooth, high-quality prints without the usual headaches. And the best part, the A1 combo includes Bambu's AMS light system, so you can print in multiple colors and materials effortlessly. No more swapping spools, just load it up and let the printer do the work. It's also incredibly easy to use. Whether you're a beginner or a pro, the one-click printing through Maker World means you can start printing high-quality models in minutes. So if you want a fast, reliable, and hassle-free 3D printer, check out the Bambu Lab A1 combo. Head to the link in the description to grab yours today. Okay, so the very first piece of news, the Starbucks. Starbucks is 3D printing one of their stores. It is located in none other than Boca Chica, Texas. If you are a regular viewer of the tech news and you kind of know or heard that name before, Boca Chica is where Starbase is. It is basically the SpaceX city that's down in Texas that is building the Starship. But Starbucks is set to make history per 3dprint.com with the opening of its first ever 3D printed store in the U.S. Located on Boca Chica Boulevard in Brownsville, Texas. Boca Chica in Brownsville, Texas. This drive-through and walk-up only location is scheduled to open its doors on April 28th. The 1,400 square foot building represents a milestone. Hoop-de-doodle-doo. It's a collaboration between Starbucks, Perry 3D Corporation, and Cobod International. Based in Germany, Perry is known for its work in 3D printed buildings and has used Cobod's BOD2 gantry-style printer for this build. Cobod, headquartered in Denmark, is a leader in construction 3D printing and holds a large share of the global market. The reason this is interesting, down there in Texas is a 3D printing building company called Icon, which is not Cobod. So why did that happen would be fascinating to know. But the textured concrete walls and layered look give the building its unique 3D printed feel. The layout includes shaded drive-through lanes, all the things. Ultimately, this is going to just kind of is an interesting example because Starbucks is like the first major brand to really embrace 3D printed buildings, and it's also the type of brand that actually could do this in a way that's useful because Starbucks is able to set an example. And these 3D printed buildings have a very distinct design aesthetic, curved walls, the layer lines themselves. And we were talking about this at a team meeting when we were discussing this section of the podcast. And we were like, the layer lines on 3D printed buildings have a lot of variation between them right now. And we're like, they're dealing with the problems we had 4 years ago. So that was satisfying. But Starbucks is making this building. Starbucks as a coffee shop is a very simple building, especially since it's walk up and drive through. They don't have to have a lot of the same amenities that another place is. So they can really embrace kind of the efficiency of 3D printed buildings around labor and materials and that kind of stuff. It is just printed concrete and it's kind of a shed. So it's just a great example there. But down there in Brownsville is near all this stuff going on there. I apologize. I got thrown by the Boca Chica Boulevard. But anyhow, 3D printed buildings kind of getting a tad more mainstream, and there's no doubt that Starbucks is going to use this as a baseline kind of example because they're able to put up stores faster by doing this and also just have kind of the technological bent on it. The next piece of news, Context reports tough year. for AM industry with declines in 3D printer shipments in Q4 2024. Okay, I read this whole report and this whole article, and there are a couple misleading things. There were declines, number for number declines in the number of machines printed in every category except entry-level machines below $2,000. That category increased by 25%. That is not brought up until about paragraph 5 of this article. Basically, what it appears to be is that the entry-level machines are cannibalizing the upper-level machines, which we have discussed multiple times before. Bambu Lab machines are pretty darn good, and they're absorbing what higher-end machines used to produce and are taking up some of that margin. So they go through it all. Yeah, everybody's declining. Here are like some key stats that they have right at the moment. That polymerization systems experienced 23% year-over-year growth. That's up, not down. Shipments of polymer systems in China were 53% higher than in Q4 2023, which is impressive growth. Unit shipments dropped 14% in North America. And then going on down, FlashForge and Z Rapid Tech saw full year shipment growth of plus 123% and plus 11% respectively. FlashForge, the plus 123%. Actually, I can't go into that number for a number of reasons. China was the top region for mid-range printers in 2024. Formlabs shipped 29% more machines in 2024 than in 2023. And lastly, Bambu, despite a minus 25% year-over-year drop, Creality was the leader with a 40% share of the market, with Bambu Lab following at 20%, with a quarterly rise of 76%. FlashForge saw shipments rise 77%, which is contrasting to the earlier number that I just pulled from FlashForge. Okay. I don't know how they're defining the difference between growth and shipments. Okay. But anyhow, 4 million 3D printers, entry-level 3D printers were shipped last year. So of those, about 2 million of them were Creality, a little less than 2 million of them, about 1.8 million. And then about 1 million of them were, 800,000 of them were Bambu. Bambu sells machines for about 500. We're going to round these out. We're going to say Bambu sells $1,000 machines and they sold 1 million of them. About $1 billion in revenue. It's probably closer to about $750 million in revenue for Bambu, which for a company that came onto the scene 2 years ago, not too shabby. And the fact that they're still so demonstrably separate from so many of the other areas is interesting. The stuff that they did at Bambu that made those machines different was just the fact that they tightly went through and integrated everything very, very well. It's always interesting to see people comment like, on my Bambu printer, it's like this. And it's like, yeah, you're using Bambu material on a Bambu machine with a Bambu profile. That creates a perfect result in almost every situation. And if you try it once or twice on the machine. But anyhow, some minor players shifted production to the U.S. Yeah, whatever it was. Anyhow, entry-level machine shipments increased. Everybody else saw a decrease. For the $2,000 to $20,000 range, that is like Bambu Lab absorbing those upper range machines. And for everybody beyond the $20,000 range, they're getting whacked by tariffs and interest rates and that kind of stuff. So just expensive machinery is a tough decision. And the low-cost machinery is pretty close to equivalent. So this is a weird report because it's really not that valuable and a tad misleading with the headlines there. But, okay. Nano Dimension, exploring all strategic alternatives to address Desktop Metal's liabilities and liquidity needs. Okay. So Nano Dimension was forced to complete the transaction of Desktop Metal. They did not want to. I'm pretty sure they did not want to at all. But at this point, it was summarized in the article actually pretty decently. This is per TCT. It was announced. What was the main number? Desktop Metal having a lot of trouble. Oh, shoot. No, I'm looking at the wrong article. Desktop Metal was... Boy, Desktop Metal. Poor guys. They tried to do a merger deal with Stratasys for $1.2 billion. And then year goes by, they lose more money, and then Nano Dimension offers them $120 million for them. They are currently worth 30 to 60 million on the public markets, but they have this deal with Nano Dimension for 120, which is a little bit iffy, which is why they have such a low valuation on public markets. They have $30 million in cash, and they're burning it fast. So it's existential for Desktop Metal to get this deal closed. Otherwise, they won't continue to exist. Nano Dimension is seeing them increasingly as kind of an undesirable asset. By the way, this is not financial advice. I am not a financial advisor. This show is for entertainment and education purposes only. But that's my disclaimer. Desktop Metal has a lot of intellectual property assets, but they do not have machine sales. They do not have the sales numbers, and they most certainly don't have any profitability to bring to Nano Dimension, which was also unprofitable at the time of the acquisition was announced, and still is. So Desktop Metal, some people are theorizing that Desktop Metal will remain a separate entity that Nano Dimension owns shares in, but Desktop Metal will effectively go bankrupt and then liquidate its assets that direction. It will be interesting to see. We do not know, and it could go either direction. So that is ongoing drama that we will continue to keep you covered on. Tune in next week to find out what happens in the drama between Nano Dimension and the Desktop Metal saga continuing on since 2024. Okay. Moving on, next piece of news. Company updates. All right, hot dog. Tangled. Tangled, we're getting caught up on. We continue to get caught up on. You guys might have actually, if you were over on the Tangled channel, you might have seen us do a release of a couple of shorts. Number of factors piled up to cause problems. Number of print farms and other people who discovered us decided, let's order 100 spools of filament or whatever else it was, which is an outlier in production capacity when a bunch of those guys pile up. And a bunch of those guys piled up. So we got a little bit behind because of that. And then our spool manufacturer shipped spools late, which caused us to be a little bit behind because of that. And then we have to do maintenance on the extruder because we have to try to make good filament for y'all because y'all don't want garbage filament. And that put us back a little bit more because we lose a production day for that. If you want to see a cool short where we have the screw jerked out of the extruder while we're doing a cleanup on it, we polish the screw, go check the Tangled Testing YouTube channel. That's where we're posting Tangled content as it kind of comes up. And literally that content is very raw. It's unproduced. It's like, hey, this is a cool thing. Take a picture. And that's stuff we do over there. So go check that channel if you want to see that. And then we'll get testing videos rolling over there again too. But Tangled effectively is getting caught up because there's been this cascading group of problems and good things. Like the demand is increasing because we make filament for $10 a kilogram. And in a tariff world, that's getting more attractive. And we are also just having normal scaling problems. The good news is that the Tangled team has kind of been built out. There's 2 or 3 people committed to Tangled now for the first time. And we are getting the production schedule laid out. So we have night shift, day shift, so that production can scale up. And we're committing another extruder to it to scale up production even more to get ahead of it. And we may introduce some of our own colors. You guys also may have noticed, if you are a Tangled member, we have partnered with Polymaker, who has U.S. production of filament, and Polymaker is supplying colors. So Tangled members get discounted Polymaker filament over on the Tangled website if you're a member. I think it's 5 or 6 colors. So the reason we did that is that, number one, it was a good deal. It was a good partnership. Polymaker makes good filament. That material is what we also use in Teleport, so people can get prototyping and color swatches from those colors. And when you're ordering really cheap black, you can also pick up the colors along the way too, all in one shipment. And now it's all on us to get the shipping cadence sped up, which is a persistent problem when you have a good product that people want. Keeping up with their want is what we're fighting with now. So we'll see how that shakes out in the dynamics of Tangled and the rest of it. We may end up... No, I'm not going to go into that right now. I don't know what it's going to do, because like Tangled, it's unsustainable to have this level of growth, because we'll just end up disappointing people. And increasingly, people are engaging with Tangled without really knowing the history of where Tangled is or what the project is. So we want to make sure that expectations are clear for everyone. But there's that. Teleport. A lot of updates coming to Teleport. Like, we're this close. We're this close, guys. We've been doing, like, all this first quarter, we have been doing a lot of back-end work, which you guys have not seen, but you have seen. Like, production rates have increased, quality has improved, shipping times have reduced. All of those things are back-end operations that we've been doing. We have not released any of the new features that we've talked about. So like photo prototypes, replace and reship buttons, those kind of things. Those are coming really, really soon. Literally, there's a little bit of brain surgery going on in the back end of it all. And those, we'll go into those updates in more detail soon. But like, Teleport is going to get radically improved, a lot cheaper, and just better overall very, very soon. So that's coming along. I don't want to release or talk about too much of that, but we should have stuff there soon. Okay. But Teleport's getting into a really exciting spot. By the way, by the time this goes out, you will probably have 5 to 7 days to start up your Etsy store to be eligible for the prize. You have to start your store within 30 days within the 30 days of April, effectively, within 30 days of when we had that announcement video, which was not April 1st. I think it was April 2nd. So you have until May 2nd to get an Etsy store connected up to Teleport and fully integrated in order to be eligible for the prize for the next 30 days. Because once you connect that store, you have 30 days to hit $1,000 in sales and report it to us, and we will pay you $1,000. So get going on that if you haven't, because the clock could be ticking. Segment, featured 3D print. Okay, we have a new segment that we've been doing in the show, reviewing 3D prints. And the featured 3D prints that we have are coming down from Maker World, because this podcast is sponsored by Bambu Lab. But the first one we have is a foldable rope hook by Engineer's Mind. It is a rope hook. This is mainly for hikers and that kind of stuff. You actually go this direction, and I want to show kind of a nice subtle little feature that they have on this, because it's actually pretty darn good design. So this is meant to hang on a rope like that, and then you can fold it up, put it in your bag later on if you want to use it like that. The design of this part, there's a few things that I want to do. And also, by the way, guys, new studio, new stuff down here, new camera, here we go. I want to show off some of these things. So this design is a little bit blown out, but you have the hook retaining nuts up there. This is all printed in this orientation. First thing that I have an issue with, these bumps for this hook should not be vertical edges like this. These are going to snap off after a little bit of use if you're using it on the regular. In order to fix that, this hook is able to flex. You don't need 2 of these bumps. You can eliminate the bottom hook bump, make the top bump a little bit heavier interfacing, and beef it up. Make it thicker and wider right here. Wider right there, so that it can't break off. It has enough structure there to do it. And then you can lock that in and it's just fine. You don't need the second latch down at the bottom. That is redundant. As far as an item, I really like this, because the utility of this for like hikers is actually a lot higher than a few folks will think. Same thing with this hinge. This hinge is like the initial first pass kind of a model. If I was refining this, you take these hinges and you just spread them out. Basically V them down there, merge them into the body of the part more, because what's going to happen is that over time, you have these 3 segments, that section is going to break out of there eventually. So this is in the realm of like cheap 3D print, but it could be turned into a really premium, high quality, robust 3D print with just a little bit of change. By the way, the feature that I really like on the back is that there was this indent put in there for the rope. I really appreciate that because it kind of creates an ergonomic signal that, hey, the rope is supposed to go around here and fall into that groove. It's a very subtle thing, doesn't hurt the print of it at all, but makes it look really good. And again, a lot of people kind of misperceive 3D printing as like cheap plastic crap and that kind of thing. But so much of that is about the design. You can make this stuff really premium, but a lot of people don't know how to design premium stuff, especially for 3D printing. And it doesn't take much. It just knows where, it's about knowing where you can push and where you can't in order to take something that's kind of clicky-clacky from 3D printing and turn it into something really premium. Okay. Not discussion, hardware is hard. Not the discussion, we're going to do hardware is hard here real soon. Boy, hardware, yeah. But not right this second. We are going to do questions from y'all first because y'all got them. And the hardware is hard conversation. Listen, I got things. People got my goat last week, and I'm going to address this. But normal questions first. Okay. Content over here. Going to last podcast. If you have a question for the podcast, make sure that you say question : what your question is. Otherwise, we're not going to answer it. We have too many comments, guys. You got to follow at least the baseline rules if you want us to be able to get these things. It's not a big lift. Go ahead. Just put in question : what you're looking for, and then we'll have this beautiful list of everybody's questions. So, question: could you do a segment on your personal journey to where you are now? I would love to hear you getting the idea and all the struggles and stuff. We've covered this. This is from Upcoming Villain. We've gone over this a lot to where we have a podcast where we go through my personal background of how I got involved in 3D printing. I wasn't a fan. 3D printing was dumb, but it had kind of a fundamental nugget of truth and viability that got me interested. And then Slant 3D has been a long road because Slant 3D has been a bootstrapped company, which is just fundamentally very difficult. In Idaho, which is fundamentally very difficult. In hardware, which is really flipping difficult. And so there's been a lot in that. I recommend going through like the history. You can look at projects we've killed. The biggest, your personal journey. Yeah, okay. It is more painful than anybody ever really lets on. That's the thing I would say for me personally. There's a romanticization around company creation that is wildly wrong. Especially if you're wanting to build a company with actual real impact. A company with actual real impact is slow to build, difficult to build, and painful to build. In fact, you can almost define how big of a problem you're solving by how hard it is to solve and how much pain it creates. You don't be stupid inside of that, but it's not fun. I do not recommend my job to anyone. And anybody who thinks that my job looks like fun or good, yeah, it has its moments. It is something that I'm passionate about and believe needs to be done, but it's not something that I would recommend that people do. For me, it's my personal motivations vary all the way from the religious to the obligation, but this is what I'm supposed to be doing. This is my mission in life, my calling, the spot that I'm built for. So why I do it has my reasons for doing it, but it's not something I recommend, and I don't think it's something that everybody can or should do. That's around the question, but again, I've gone through this before and other sorts of stuff. Maybe we'll do a discussion topic one day about like, what's the worst pain you ever felt with that? I'm like, I don't feel like sharing that right now. Red Amaleki? Yeah, we'll try that. Are you going to update your shipping terms on the Tangled website so we can see what free shipping really means without having to sign up for a membership to see the terms? Free shipping means free shipping. If you're a Tangled member, shipping cost is $0 inside the continental United States. That membership only applies to the continental United States. If you're international, I don't think we even offer international shipping. I'm not sure. It might be there, but it's really expensive because filament is heavy. One of these days we might do international distribution for Tangled, but we got to scale it more because you got to move container loads of the stuff around. And again, that's not really like the goal of Tangled, so I don't know when that will happen. But yeah, the terms free shipping means free shipping. Simple as that. Can you elaborate on your pick and pack guidelines? Is it a flat rate or is it a price per item placed in the box? Can a teleport user supply kits of parts or hardware to place in each order? I'm familiar with pick and pack being a price per item placed in box with a particular So pick and pack is integrated into the cost of each part. Because it's effectively, a pick from the build plate and packing of that build plate of one part or multiple parts, whatever it happens to be. It is a flat rate fee baked into the teleport pricing, but it's baked into the teleport pricing. And then printing cost is on top of that. For anybody who's not familiar with this, there is the cost of manufacturing the part, of growing the part, which is the material, the print time, the post-processing labor, that kind of stuff, which varies from part to part. And then there's the pick and pack cost, which is the cost to move it from that machine and then place it into a box and all the cost of the box and the cost of paper material, which is pretty much universal because we use standard size boxes. That packing fee, Amazon charges a minimum of like $3.15 or $3.16 for pick and pack of an item. We're less than that. Because we're a tad more efficient than Amazon. Amazon has a lot of warehousing fees attached to that as well, but 3D printing has a lot of cost advantages. And we're also just a very efficient organization. Question. I am interested in buying the color filament, but can't really afford buying 3 rolls of every color. Is there a way to do a rainbow or a full color pack where we get 1 spool of each color instead? Maybe someday, but from a process... from an operations standpoint and making sure we don't screw stuff up, that's a variation that's not really very common. Tangled is all about optimization and that kind of thing, not SKU count. So we're going to keep it fairly simple. And we know that this limits us to certain types of users, but that's on purpose. Like Tangled is a very focused kind of a project because it was gravy. Tangled initially was not like a core initiative of the company. It was something that kind of grew up, and we refer to it playfully right now as the redheaded stepchild. But it has been that. But Tangled, fantastically, has been like a surprisingly really good business in a number of different ways. It's not very profitable, but it's a good business. Operationally, process-wise, branding-wise, like a lot of things just came together to work really well, and it's something that people really like. So, but yeah, a rainbow set, it's a single SKU with 3 SKUs that just creates complexity in our overall order flow, and right now we're trying to keep up with orders as it is. What is your interpretation of the Etsy seller rules concerning POD sales? Oh, interesting. I ask because your suggestion for the $1,000 challenge of grabbing models from various sites that can be legally downloaded, printed, and sold. By downloading another's models and selling through your teleport service, I would have no hand in creating the product, and that appears to go against Etsy's rules. So, I am not up to date on this week's version of Etsy because they move it around. But Etsy, to my understanding, had effectively split, and when we were doing it, they had effectively split print on demand over here and then handmade over there. So print on demand could be on the site and they were fine with it, but it was effectively categorized as print on demand. They're like, okay, these are t-shirts, the people didn't sew them, but the artwork might be theirs. As far as downloading 3D models and 3D printing them, I think this is a gray area that no one on Etsy cares about. I think the 3D printing world on Etsy is much smaller than so many other components of Etsy that they're fine with it. And from my observation of the sellers on Etsy, it's fine. It has not been a problem for anybody. So Etsy could change their rules or their enforcement or how they feel about it this week, but that is just the nature of the platform. That literally is true of every platform. Literally, Shopify has moderation on their websites. And I'll bet you didn't know that, but like your Shopify website is not like fully owned by you. If you start selling Batman merchandise on your Shopify website, the Batman folks will know because Shopify tells them, because Shopify doesn't want to get sued. So there's that. What filament would you recommend using for functional and strong prints with an enclosed printer? There's a bajillion of them. ASA is fine. Nylon is fine. PETG is fine. I'm not going to go into that very much because, quite frankly, we're just not quite the right YouTube channel for that. Question. Gabe, please review and comment on the suggestion thread, especially but not limited to the Slant 3D response. Hang on. Let me see if I'm going to get in trouble. Person, bunch of replies. Says it has 4 replies, but I'm only seeing 1. It is a conversation around would teleport a material bundle that can be purchased for prototyping at home. So the materials that we just released on Tangled are the materials inside of Teleport so that you can get them. They are a set of Polymaker colors for many of the colors. And we are working on building out a swatch kit and more photos. We have a quality video that shows them all off over there. If your parts aren't up to that quality, send them to us, please, or have us refund, reship, or repack them for you. As far as a machine that mimics your production printers, don't do that. If your part is dependent upon a specific machine or particular settings, your part is not ready for production yet. Your part should be robust enough to be produced anywhere at any time with any material. That is a good part, and you will have better quality results. If you are trying to tune in to the particular settings and the particular machine and so on and so forth, you'll never have a match. It will just not exist, because it's the difference between you with your home machine is a person carving a chair versus a factory making a chair. They're not the same thing, and yours will be different. And ours will be different from that. So if you're trying to tune in perfectly for it, don't do that. Design for the FDM process and make it robust within the FDM process. That is the best advice I can give. Make a good manufacturable part for 3D printing. Question. When will Teleport have more material color options like matte blue, matte green, matte brown? Ooh, there's a theme. Those would match design objects for the living area and look less cheap than the glossy PLA. We agree with you. I'm going to say soon. Yes, they're like I say, Teleport. Like I was discussing earlier, Teleport is going to have pretty stuff is going to start breaking loose really fast over on Teleport. Is PETG on Tangled roadmap? Sort of. Not really necessary right at the moment because PLA is $10 and that's the operating goal. PETG we will release on Tangled fairly soon. Again, once we're kind of caught up and comfortable. Like we want to get to stasis. When will Teleport have TPU as an option? In the future. What are your thoughts on the things taking over their print on demand? I can't comment on that. Are you still planning to open a factory in Europe, and is there a timeline in the future? I'm sorry to be a bit ambiguous about some of these things, guys, but like they're operationally just like part of the business and part of roadmap, and we're growing up as a company, so there's certain things to where like we can't telegraph some of the stuff that we're doing, and how it relates to other folks and so on and so forth. So anyhow. Okay, that's comments. Okay, discussion topic. Oh, I'm excited for this. I'm so excited for this. Okay. So, why is hardware hard? Let me rev up for this. So, a hardware company is the hardest company you can possibly create. Let's just set that down. Let's base that right there. There is a trite little phrase out there that says, "Oh, hardware is hard." That does not begin to hit how difficult hardware is. So let me get some of this in here for you. Let me just do this. Let me just talk about this. Hardware's you don't even know. Okay. So, hardware's stupid hard. Let me contrast this against something else. A software company. Let's say you're building, I don't know, Twitter. Not Twitter. Yeah, I can say Twitter. Twitter doesn't exist anymore. So, Twitter, the software company is like writing a book. It can be done with one person in a dark room. You might have a couple of people. It is thought manifest as a product and then copy and paste it around. That is what software is. Software, just like writing a book, the creation of software is exactly the same as the creation of the book. And in fact, great software developers have a lot in common with great authors. There is a creative and a structural control and knowledge about that, and the entire thing weaves together beautifully. The thing about software and a book is that it's fully contained in this imaginary world. The digital world is imaginary, fully constructed by humans, and perfect, outside of having to deal with the stupid HTTPS protocols and that kind of stuff that people agreed on because dumb reasons. But software as a system is a constructed system. So everything is meant to work and can work, and the worst thing you're generally dealing with is bad documentation or someone else's bad code that does not run as well. But very often it's functional, but it might have bugs and that kind of stuff. If you're building your own software project, you get to make it as perfect as you can possibly make it. And the computer does precisely what you want. 2 + 2 always equals 4. As it should. The world is perfect. That's writing a book. Writing a book can be done in a coffee shop with a laptop for no money at all. That book becomes famous. You sell 1 million copies, become a billionaire. People love Harry Potter. Now you have to make a movie. And the movie takes that book. And that movie costs hundreds of millions of dollars to make. Because other people have to get involved. And you have to film it. And it rains some days. And wands don't exist in the real world. And there's monsters that you need to show to people but aren't real. And then you also have to market that movie. You have to package that movie. You have to make ads for that movie. The book was just there. You had an editor. 3 or 4 people went through, polished that book, and then it was out the door and on shelves. The movie. This is the difference between hardware and software. And this is why hardware is so hard. Okay. Hardware is so hard because it is fully comprehensive. At its most fundamental level, hardware is twice as hard as software because most hardware has software. And then it also has hardware on the side. So you're at least twice as difficult. Now, let's just go and compare if those two things are equivalent. Because they're not. Software, like I say, perfect world, digital thing, wands, you go with one Wingardium Leviosa said, there it goes, and it works because you said it does. You set the rules. Hardware. Physics. Well, the apple drops this fast. Unless you're at a different elevation and air pressure was different, or you plugged it in with a USB and the manufacturer used kind of a cheap chip, which is a little bit slower than what you thought, so the USB port doesn't work anymore. Or you got a display and 1 pixel goes bad in that display because there's 4 bajillion pixels in that display that all have to be perfect. And then you go to the manufacturer and you say, here, make this, and then you don't include tolerances inside the design, and the manufacturer makes it to the tolerances that are inside their spec sheet, but that's not what you expected. And then you get it back and you make 1,000 of those, and they're wrong, so you go make 1,000 more, and then you rework the mold, and then you go through all this, and then you design the mold, and you're like, oh my gosh, the mold was garbage, and we can't actually mold this because we made a perfect square, which doesn't have a draft angle on it. And then you go ahead, finally get the part back, and you're like, oh, there's my prototype. It's fantastic. Oh, we carved that together in our back garage, but now we have to have 5 to 20 other people, other organizations make parts of this, and they all have to make it perfect in order for it to come back together the way we expect it to go. And none of that happens. So hardware is much harder than software by itself, but a hardware company still has to have software. So anybody who's ever out there like, oh yeah, software company, I could go build a hardware company, you have no idea what you're dealing with. Okay. Let me break down that moment just a little bit for you. Hardware is not a single discipline. Software is a single discipline. A programmer can pretty much learn any language, make it talk to other languages, deal with APIs, interact with the general digital world as a whole. A reasonable developer is able to be fairly cross-functional to a degree. They can ramp up a server, build a website. You can get Twitter knocked out in a weekend or so, that kind of a thing. There's specialties within it, but beyond that, that's where it is. However, if you make this pen, or you want to make a phone, or you want to make a robot, or you might want to make a 3D print on demand service, you have to have a very multidisciplinary team. You don't have just software developers. And you have to have a team that everybody kind of understands the context of what they're dealing with. The software guys have to understand what the chip is, what its latency is. The chip guys have to understand what the battery is, what its time, what its discharge rate is. The battery guys have to understand what the thermal properties of the case they're going to put this battery into is going to be. The case design guys have to understand how the mold works. They have to understand what materials and plastics are out there. And then all of them have to get into a room and work back and forth to say, we're going to make a box this big that does a thing. How do we make trade-offs and exchanges and still end up with something reasonable and not a giant flipping compromise? You need so many more people, so many different domain experts. By the way, this is just the creation of the product. Software, when you ship it, you post it on your website, and then people have access to it. And the website is the packaging. If you're making a hardware product, not only do you have to design the hardware product and make sure the software works on it well, too, then you have to put it in a box and make sure it can ship to a person reliably, and that box is nice or enjoyable. Packaging design is a whole nother thing that you don't really think about. Oh, what is a barcode? What does it actually do, and why do you have to have them? Software developers don't have to think about this. Yeah, put it on the internet. Well, got a bunch of downloads yesterday. Yeah, hardware, just the mere distribution of it is harder. Maybe you're selling it in a retail store. Now you have to design that package to look good on a shelf. Software, again, SEO, make a YouTube video, buy a Facebook ad. Yeah, people get it. It's easier. Software, no, wait, let me go back to software again here. Software, if you're wrong or it's broken, you can change it and then it's all fixed. Maybe not everybody updates it. Maybe people have to re-download it, reinstall a new version in worst case. Hardware, if it's broken, well, sucks to suck, it'll be upgraded on the next round. I guess those phones are going to blow up for about 6 months and then we'll get the new one. Or we can buy them all back, lose $1 billion, and do it again if you can afford to do that. So as a hardware startup, you generally get about one swing, and then you're out of business when something goes wrong. So you have to be fantastically robust. You know the Nothing phone? I don't have it on me. I have a Nothing phone. A Nothing phone, the Nothing company, they started out with headphones because they were like, headphones are easy. Let's start making headphones because that's a hardware product that we can do well and that we can sell a bunch of. The springs in them were too weak, so they would not charge. And they had to fly to China and take over the factory in order to get the springs upgraded so that the things were made to spec. Because the manufacturer, that's the kind of stuff that goes wrong with hardware. And once it's made, it's made. You can't roll back of the code or update it or anything else. So hardware is much more permanent. You get one swing at it. You're dealing with the messy world. You have a really multidisciplinary team. You have to have a really multidisciplinary team or really wildly polymathically skilled people in order to create this kind of stuff. Folks who are just experts in multiple areas. Hardware has timelines. Some software projects have timelines, but Apple Intelligence apparently doesn't. Software, let's say you're making a planning app or Twitter or whatever else it was. You can launch that whenever. Hardware has to launch by Christmas. Otherwise, you have a full year you have to survive until the next Christmas when people are spending money on that stuff. I'll admit some softwares have some cyclicality, but generally, people will download a game anytime. People will download a calendar app anytime. People will download Twitter anytime. People will download the latest AI app anytime. They'll at least give it a shot because the cost of trying it out is so low because it's generally a free download and then you can upgrade to the subscription. Whereas hardware, people have to buy it, which means you're dealing with physical timelines, which means that if you're going to introduce a new phone, you got to do it in the next 6 months. Apple has their phone designed 12 months ago, and it's just running through the factories right now. And they have to hit the timeline. Because if they're like, oh, shucks, it's a month late is January. No, you're going to ship in November. Deal with it. So, yeah, timelines actually exist inside of hardware. Hardware is expensive. Hardware is fundamentally expensive, especially if you want to make an affordable hardware product. Let's go to phone. Let me use Tesla as an example in this one. Tesla, the Model 3 ramp in 2018. They had never made a bunch of cars before. They made tens of thousands of cars with like the Model S, but they had tens of thousands over 5 years. But then they get to the Model 3 and they're like, okay, we're going to make 5,000 per week for an extended period of time. This is a different monster. In order to do that, Tesla has to talk to the guys who make the tires or bolts or whatever it was. Call all the suppliers and say, hey, we need enough of these nuts and bolts for 100,000 cars. And in order to get a sweetheart deal, we're going to commit to 500,000 cars over the next 3 years. And if we don't hit those numbers, then we owe you fees because we're late and we're welching on the contract. And all those suppliers say, okay, here come 100,000 parts. When those parts arrive, Tesla has 30 days to pay them for the parts. Ideally, Tesla has taken those parts and turned them into a car in those 30 days that they have sold so that they can then pay the supplier off. The reason the Model 3 ramp was so painful and so dangerous to Tesla is because they had all these suppliers shipping parts. Those parts were arriving, but they weren't getting turned into cars very fast because the robot was crooked and the line was down and that person wasn't trained and somebody hammered in a screw and so on and so forth, building a factory, making hardware, trying to make physics work to where you're just dealing with messes all the time. And it's wildly fragile to keep a factory together when everything is about to break. Parts are arriving. And they couldn't get cars out the door, which means that they're having bills show up and they're running out of cash because cash is going to start getting burnt faster and faster as those bills come due. And you delay and you stall and you wheel and deal and so on and so forth. And you sell a few cars. But that ramp is so dangerous. Hardware is just expensive because you have to pay for all of it back here and then you sell it up here at this time. Again, like last year, Slant 3D, when we prepare for the Christmas season, we stock inventory, material, machines, so on and so forth for the Christmas ramp. If that Christmas ramp doesn't come or whatever, something goes wrong and the demand isn't where it is, we still have all those bills to pay for 3 months. And we probably don't get paid until like end of December or even January or something in some cases. That can be painful and can be existential for the company. So hardware is just hard. It's expensive just from a business model standpoint because you buy upfront goods and then you deliver them later on. There are financial tricks in there where you can mess with suppliers and play with it, but generally if you're a manufacturer, it's limited, especially if you're in a startup. At the start, you have prototypes. You have to buy all the molds to make one part. They're cheaper molds, they're aluminum molds, but they're still tens of thousands of dollars. That's to get your first piece, and then you find out, oh, that case doesn't work. Rework it all, let's try it again. Software, you push code. It costs nothing. It costs time. Hardware, you have the time, and then you have all the flipping hardware you got to buy on top of it. You have an expensive developer or engineer or whatever it was, or designer, and then you also have to pay for their creation of the object, the machining, the manufacturing, the shipping, as opposed to just paying for like a developer, which is really expensive compared to like a mechanical engineer. Developers are really expensive, but a really expensive developer, but they ship code immediately. And there's no other tangential costs associated with that. You have a guy with a laptop. With hardware, you have the salaries, and then you also have the actual things being made, which are expensive in and of themselves. And if you want to iterate quickly, it gets really expensive. Hardware is set and frozen and can't be changed. Yeah. Once you design set on your phone, that's what you're selling. And if people don't like it, sucks to be you. Guess you're going broke, or you're going to have to rework that phone next year. You're working with physics, not the perfect digital world. Talked about this. Let me give you a hardware problem that is like fantastic. A button on the side of a phone. This is how this goes. We need that button to last for 100,000 cycles of people turning it on and off over a 3-year lifespan of that phone. People bumping it, dropping it, putting it in the toilet. We need a button that is waterproof and can be hit 100,000 times, sit in a dirty lint pocket with a bunch of dust and dirt around it, and then have the dog grab and drool it on it, and have that button still work. That is an engineering problem that is difficult. Really quite difficult. And we need it to be clicky. Oh my gosh! That is how hard the problem is. If it's software, well, you give it a little sound effect or whatever else it was and move it down there where it's comfy and so on and so forth. But no, hardware, you have this fundamentally difficult physics problem of making a button, a piece of steel, bend and flex 100,000 times and make sure that it's reliable and good on every one of those and doesn't fail in a drastic way. And then you also have to tune the feel of it. You don't just have to achieve that engineering feat, that functional achievement of a button that operates for that period of time. You also have to make it clicky. This is why hardware is so much fucking harder than software. Software, we tested it. Run 100,000 tests. There, yeah, it didn't break in all the variations through our testing. Done. Showed it to the users couldn't break it. Cool. Oh, one guy did break it. We update it. No. The button, you have to design that button, test that button, run it through a machine, push on it 100,000 times, and then try again. It's really hard. Hardware is unscalable. This is a little bit of a misnomer, but not a misnomer, misunderstanding. Many people think that hardware is unscalable. That's very wrong. Pretty much any business is scalable if you know how to create the business or operate within the business. So scalable is such an overused term that it's just wrong. But it leads to why people don't fund hardware companies. So like from a financial standpoint, hardware is really hard because you have to do it with a loan or your money. Investors aren't really buying in very often. If I come up to you and say, I'm going to make a smartphone, they're going to be like, that sounds like the dumbest idea I've heard this month. And I've heard some doozies. But yeah, hardware just is not attractive because it is this hard to just make it. All the things I just discussed of the factory, the financials, the lead time, all of it. But in addition to that, once you have a product that people want, if you have a software product, the marginal cost of creating another copy of that product is zero. Copy and paste Microsoft Office and it goes on another computer and it costs nothing. There's a bunch of upfront R&D expense, but then it's done. Hardware, if I want to make a phone and sell you a phone, well, I sold you that phone. I designed and made this one phone and I sold it to you. Well, now I got to go make and pay for another phone and then sell it to you, and then make and pay for another phone and sell it to you. Whereas with software, it's just like, made the software, subscription fee, $10 a month from everybody who's using it for forever. Hardware, I can only sell it to you one time because subscriptions for hardware don't really fly right now. And you sell it once and then you're done. And this is the long-term problem with hardware. Once you've sold the thing to them, if you've done a good job and you've made a piece of hardware that is reasonable and good, the person will be able to use it for a long period of time. And you will eventually sell it to everybody, and then you're done and the company dies. So what do you do then? You have to create very innovative business models because you cannot default to the subscription. You have to have something like a consumable. This is why printers are cheap, but the ink is expensive. That's the trite little example there. That is how they've monetized hardware. It had Slant 3D. We are a hardware company, but we've morphed into kind of more service-based and a bigger software focus to where software gives our hardware a greater reach to where, yes, we have to build a machine, but that machine can be used by one guy, 100 guys, 10,000 guys, whatever it happens to be, as opposed to just selling that machine to someone and then hoping I sell a machine to somebody else. So hardware has all of these challenges that have always existed and always been well understood. Perfect hardware story, Ford Motor Company. Ford, in the early days, was the $1 trillion company because they were selling a car to everybody for the first time. So they were smelting iron and popping out Model Ts, and they had full stack control all the way through there. But then Ford sold a car to everybody, and nobody needed a new car as fast as they needed their first car. So what did Ford do? Well, they're like, well, we have all these cars. Now we can sell you spare parts. So Ford morphed into this spare parts company that sells a car basically at cost and then makes the money off of you for the spare parts when it's out of warranty. And that's how they maintain revenue growth over time. And now they're at a point where like, okay, well, there's a lot of other car companies doing the same model. We're all diluting ourselves. So where do we go from there? You can't make money selling the car because we're all at this pricing and we can't just jack up prices and we don't know how to make our cars special. So that kind of stuff. But that's like a traditional hardware trajectory. Make a Model T for everyone. Sold a Model T to everybody. Now we're going to decline in size so we can either be smaller, which the stock market doesn't like, or figure out something else, which means you have to innovate a new business model. And hardware has really difficult business models because you're trying to get people to buy an object multiple times. And that's really tough to do because that's never happened in human history. So, why is hardware so hard? It's really multidisciplinary. You probably have software in addition to it, so you just have more than what a software product does. It's frozen for forever. You have upfront expenses. You have the cost of salaries plus the cost of the actual stuff itself while you're developing it, which is more than in software, where you have a guy with a laptop. You have long-term risk of making sure your business model can sustain for years, decades. You have short-term risk of you can't change the product if you're wrong, and you're probably going to be wrong. This is why we started a 3D printing company. We started a 3D printing company in order to allow for the reduction of risk of creating products, because it's free to create a product on Teleport versus going and getting a mold and making 10,000 of them and hoping people sell them. We literally created Teleport to help with a small facet of the hardware problem, to where at least now somebody who's making a vase or a widget or a toy can at least get it manufactured for free the same way you would with software, but without and not having to deal with all the hardware problems. That's what we're doing here at Slant 3D, trying to help with just the production of the plastic parts. There's still all the other stuff. Really multidisciplinary team from electronics to software to injection mold design all the way through. And then you're just dealing with the messiness because hardware operates in the real world and the real world doesn't operate perfectly. So it's just harder to make. So if anybody ever wants to know, why is hardware so hard? That's all why. It's more, and it's more difficult all the way through. Because nothing is there to help you. Software as a discipline is the most fantastic business model, most fantastic product creation and distribution model in human history. It is magical what software is and what it's able to enable. And that is why there is so much value over there and why it got venture capital and why venture capital did not really come about until the digital age, because software has these really outsized returns for fairly low input, whereas hardware has exceptionally high risk, really high input, and wildly unclear future prospects. Because number of users does not convert into long-term value. Just because Ford sold a Model T to everybody does not mean that every one of those people is going to buy a Model T again. That's the problem with hardware. Software, you can kind of lock people in. Well, it works with all my stuff. Hardware doesn't have that kind of ecosystem, mainly because it's not controllable. And it doesn't scale and grow so quickly that people become dependent on stuff. So, yeah, hardware is harder than software. And operating and managing a hardware company and a hardware team is a completely different monster from creating a software team or company. So hopefully that helps give some insight as to why hardware is hard. You have no idea how hard hardware is. Have a great day, everybody.